Welcome to Power System lectures. Now we are discussing with per unit representation of power system. This is the single line diagram of power system. The whole power system consists of a source, that is synchronous generator, and transformer. Here this is step up transformer at generation side, and the line, this is step down transformer at load side, and this is load. The whole power system consists of these elements, and we discuss one by one how the per phase representation of these elements and then per unit representation of these elements. Next one is synchronous generator, that is source, and the representation of synchronous generator in an electrical equivalent circuit is this. Here three phases, phase A, B, C, and there is one source, and this is source impedance for each phase, and neutral is grounded. This is star connected, and it is a balanced system because in a balanced system the magnitude of EA, EB and EC is equal, and EA value is E at an angle 0, EB value is E at an angle 240 degree or minus 120 degree, EC value is E at an angle 120 degree or at an angle minus 240 degree. Because each phase is 120 degree spaced, so we get this. For balanced system only we get per phase system analysis. So this is possible if the system is balanced. And the currents in neutral is the sum of currents in all phases, that is IA plus IB plus IC, and these currents also spaced by 120 degree and the magnitudes are same. So IA equal to I at an angle 0, IB equal to I at an angle minus 120 degree, IC equal to I at an angle 120 degree. So IN value equal to the sum of these currents, I at an angle 0, I at an angle minus 120 degree plus I at an angle 120 degree. I value is common here, so 1 plus 1 at an angle minus 120 degree plus 1 at an angle plus 120 degree, and we know that 1 at an angle minus 120 degree is written as cos 120 degree minus j sin 120 degree, and 1 at an angle 120 degree is written as 1 cos 120 degree plus j sin 120 degree. Here plus 120 degree minus 120 degree into j are cancelled, and we get I into 1 plus cos 120 degree we can written as minus cos 60 degree. This is also same, minus cos 60 degree. Cos 60 is 1 by 2, so minus 1 by 2 minus 1 by 2, we get 1 minus 1 into I, that gives 0. So the current in neutral is 0. Now per phase network of generator is this. In each phase the magnitude of source voltage is same, and in each phase the impedance is also same. So we can represent the generator in per phase form: a source voltage in series with reactance with a voltage V volts. This is A, this is neutral, this is A phase. We can represent synchronous generator in per phase network as this. For transmission line we can simply represent as it is an impedance. And next, synchronous motor. Synchronous motor is same as synchronous generator with only change in direction of current. Direction of current is from in this direction. Induction motor. Here the equivalent circuit diagram of induction motor. This is primary side and this is secondary side. Here secondary is short circuited. We know that rotor is short circuited, and primary resistance and reactance, secondary resistance and reactance R1 jx1, R2 jx2, into S. S is slip. In induction motor, the voltages here, the voltage is same because here 0 volts and here also 0 volts. When the circuit is referred to primary, here Z1 and Z2 dash, these are impedances referred to primary, and the voltage, now the voltages here this side and this sides are same, that is 0 volts. So we can neglect this part, we can write as, we can take as Z equivalent only. Simply induction motor can be represented as Z equivalent. Now transformer. The equivalent circuit of transformer is this. This is primary impedance and this is secondary impedance. The supply at primary is V1 and secondary voltage is V2. The EMF induced in primary is E1 and EMF induced in secondary is E2. And the circuit referred to primary is here. The equivalent resistances are Z1, Z2 dash, and it is Z01. We can represent it as Z01. Z01 equal to Z1 plus Z2 dash, and Z2 dash we can written as Z2 by K square. And refer to secondary, it will be Z02, that is Z02 equal to Z2 plus Z1 dash. Z1 dash can be written as Z1 into K square, and Z02 equal to Z1 into K square plus Z2. Same, we take common K square, we get Z1 plus Z2 by K square. This is Z01. Here we see Z01, that equal to Z02 equal to K square times of Z01. We get this, and we see this later. We see the per phase representation of overall power system. This is generator and this is transformer 1. This is line. This is transformer 2. This is synchronous motor and this is induction motor. Same as we see these elements in separately, and now with combined circuit. And for per unit representation, we can neglect this separation of circuit. So for getting transformer in per unit form, we will see here here in per unit form, the voltage induced, that is E1 per unit and E2 per unit, are equal. So we can take the voltages here and here, this side are as 0 volts and this side also as 0 volts. So we get this as final per unit representation of transformer, that is Z02 per unit or Z01 per unit. This is the final per unit representation of the power system. This is generator, and transformer simply we can written as Z01 or Z02 in per unit, and Z line per unit, Z01 per unit of transformer 2, and synchronous motor, induction motor. Per unit, the per unit value is the ratio of actual value to the base value. There are many advantages by using per unit value.